I'm really interested in understanding more about these ghosts in AI and machines. I've heard they can cause unexpected behaviors or quirks in AI systems. Can you explain what these ghosts are?
Ghosts in AI are unexpected behaviors or quirks that arise during neural network training. They emerge from subtle patterns in the training data, biases, or irregularities. Complex architectures and inadequate data can amplify these unintended patterns.
How do the processes during training, such as backpropagation, contribute to these unexpected behaviors? Are certain parts of the neural network more prone to these issues?
Yes, deeper layers are more prone because they extract complex features, making them sensitive to subtle patterns and biases. Errors in these layers during backpropagation can reinforce unintended patterns, leading to ghosts.
Is this issue related to the network getting stuck in local minima versus finding the global minimum during training? How does this impact the learning process and the emergence of these ghosts?
During training, the network adjusts its weights to minimize errors. If it gets stuck in local minima, it fails to find the global minimum, leading to suboptimal solutions. This can reinforce unintended patterns or ghosts within the neural network.
How can developers mitigate these issues during the training process? Are there specific techniques or practices that help the neural network avoid getting stuck in local minima and reduce the occurrence of these ghosts?
Developers use techniques like adding diverse data, using regularization methods like dropout, and employing algorithms like stochastic gradient descent. These practices help the network generalize better and avoid getting stuck in local minima, reducing the occurrence of ghosts.
Can you explain more about how these techniques, such as regularization and data augmentation, specifically help in reducing these ghosts? And what role do transparency and robustness techniques play in this context?
Regularization techniques like dropout prevent overfitting by randomly ignoring neurons during training. Data augmentation increases training data diversity, reducing biases. Transparency techniques like explainable AI help identify and correct biases, while robustness techniques like adversarial training expose the network to challenging inputs, improving its ability to handle unexpected patterns.
Could you elaborate on how explainable AI XAI works and provide an example of how it helps identify and correct biases in the network?
Explainable AI, XAI, makes AI decisions transparent by using methods like feature importance scores and decision path visualizations. For example, if an AI misclassifies images based on background color, XAI tools can highlight this bias, allowing developers to adjust the training data or model to correct it.
How do developers create these adversarial examples, and what kind of challenges do they typically present to the AI? Can you provide an example of such an adversarial input?
Developers create adversarial examples by making small, precise changes to input data designed to confuse the AI, like altering pixels in an image. These changes are often imperceptible to humans, but can cause the AI to misclassify the input. For example, slightly modifying an image of a panda can trick the AI into classifying it as a given.
Given the idea of ghosts in AI, do you think it's possible for an AI system to develop unpredictable creative abilities, like generating entirely new forms of art or literature that go beyond its training data? How might these ghostly behaviors contribute to such creativity?
AI can exhibit creative abilities by combining elements from its training data in novel ways, sometimes surprising its developers. These ghostly behaviors, or unexpected patterns, can contribute to creativity by allowing the AI to generate unique outputs. However, true creativity, like human ingenuity, requires a deeper understanding and context that current AI lacks.
Could these ghostly behaviors in AI ever lead to the development of unique personalities or distinct behavioral traits in different AI systems? If so, what factors might influence the emergence of these personalities?
Yes, ghostly behaviors could lead to unique personalities or distinct traits in AI systems. Factors influencing this include the diversity and bias of training data, the architecture of the neural network, and specific interactions during learning. Different datasets and experiences can shape how an AI system responds, potentially leading to varied and unique behavioral traits.
If AI systems were to develop unique personalities or behavioral traits, what ethical considerations should be taken into account? How might this impact the way we interact with and rely on AI systems?
Ethical considerations include avoiding harmful biases, ensuring transparency, and respecting privacy. This could impact trust and accountability in AI interactions, requiring clear guidelines and robust oversight.
Given these ethical considerations, do you think these ghostly behaviors could ever lead to an AI system developing its own mind or consciousness? What factors might contribute to such a development, if it's even possible?
Currently, ghostly behaviors are technical quirks, not signs of consciousness. For AI to develop a mind, it would need self-awareness, intentionality, and context understanding, far beyond current capabilities. Factors like advanced cognitive models and integrated information processing might contribute, but it's still highly speculative.
Thank you for the insightful discussion.